Assalamualaikum to Madam Siti Aisyah Tumiran. We are from Group 3. We'll present about random variables by variate distribution. Our list member of Group 3 is Alia Safira binti Astri, Ben Johnson bin Sin, Gabriel Dennis, Maliana binti Jafi, and Muhammad Adib Zahiri bin Ahadin. So what is bivariate distribution? Bivariate distribution are statistical methods used to show the probability of two random variables occurring. The most common methods used to display this information is with a table. To have a bivariate normal distribution or a joint normal distribution, both random variables need to be normally distributed and the variables need to be independent. The results of one variable cannot affect the results of the other variables. I will pass to the next presenter.
Okay, we move to the real world application, and we choose engineering. So, bivariate distribution are applied in engineering to model the joint behaviors of two variables, such as relationship between the force applied to string and the resulting displacement of the spring. Also applicable to representing the height and weight on certain population. We move to the next slide. Problem. The problem is in a height and weight population. The question is, consider a bivariate distribution representing the height x and weight y of a population. The joint probability density function is given by fxy equal to kxy for 0 less than or equal to x less than or equal to 1 and 0 less than or equal to y less than or equal to 2. A. Determine the value of the constant k to make fxy a valid probability density function. And for question B, find the joint probability that a randomly selected individual has a height between 0.2 and 0.6 and a weight between 0.5 and 1.5. We go to next presenter.
I'll be explaining the solution for A. So to find the value of the constant k, we need to ensure that the joint probability density function integrates to 1 over the given range. So we have the function of kxy, and the range for x is 0, 1, and the range for y is 0, 2. So in order to find the constant k, we need to take out the k from xy, so we will be left with xy. So first we need to integrate x, which we will get x2 over 2y, and then we need to insert 0, 1 into x, which we will get 1, 2 over 2y minus 0, 2 over 2y. So next we will integrate y, which we will get y over 2. The same as x, we need to insert 0, 2 into y, and then we will get y2 over 4. And then we will get 2 over 4 minus 0, 2 over 4 equals to 1. So k, we will have 4 over 4, which therefore the value of the constant k is 1. Next slide. So to determine fxy a valid probability density function, so because fxy we get 1, so the JPDF fxy is JPDF since fx bigger it equals to 0 and fx equals to 1.
All right. For the solution for B, so B, we must find the joint probability that random selected individual has a height between 0.2 and 0.6 and a weight between 0.5 and 1.5. So as we can see the solution, first and foremost, we must assign it in assign the range given between height and range as shown as the first line, and then uh, secondly we secondly we im- input the given equation from the question, which is kxy for the second line, and the next step we uh, integrate it with the spec of x and substitute it by 0.6 and 0.2 and 0.6. After we substitute it into it, and we will get k over 2 uh, 0.6 power of 2 minus 0.2 power of 2 times y, the spec of y. Next slide. Okay, after we get the after we integrate the spec of x, we integrate it the spec of y. So we will get after we integrate it, we will get y power of 2 over 2. So we substitute the upper limit and the lower limit, and we will get in the third line 1.5 power of 2 over 2 minus with 0.5 power 2 over 2. Then after that we solve it, and we will get the answer 1 over 2 times with 0.36 minus 0.04 and 2.25 over 2 minus 0.25 over 2. Then after that we solve it again. We will get 1 over 2 times with 0.32, and for the x side, and for the y 2.25 minus 0.25 over 2, and we solve also the y part, and we will get uh, y part, and we solve also for the x part. We will get 0.16 2 over 2, and we solve it when until we get the final answer, which is probability of 0.2 less than or equal than x less than or equal than 0.6, 0.5 less than or equal than y less than or equal than 1.5 is equal to 0.16. So we can conclude that the correct joint probability that randomly selected individual has a height between 0.2 and 0.6 and a weight of 0.5 and 1.5 is 0.16.
So we move on to the Q&A session.
Why bivariate distribution used to analyze the relationship between two mechanical variables?
So the answer is bivariate distributions are commonly used to analyze the relationship between two mechanical variables because they provide statistical frameworks for understanding how the variables are related to each other. By modeling the joint distribution of two variables, we can gain insights into their correlation, dependencies, and other statistical properties.
Okay. Next, why Bevel distribution is used by engineer to study between force applied and resulting displacement of the spring.
All right. It allows them to analyze and model the behavior of the spring system in context, characterizing the relationship, correlation modeling, dependence modeling, parameter estimation, probabilistic analysis. Engineering can gain insight into force displacement, relationship of spring and make informed decision in designing, optimizing, and analyzing spring systems.
So the next question is, what is the function of using bivariate distributions on representing the heights and weights of certain population?
In so the answer is in the serve function is statistical analysis and modeling in the context of descriptive analysis, correlation and dependence, predictive modeling, biometric analysis, and finally the statistical inference. So by using the bivariate distribution, we can show the height and weight of the population relationship, and it's helped us to understanding more about the relationship between these two variable, and we can make a prediction. We can show the patterns and facilitating statistical analysis and inference.
Okay, in conclusion, favorite distribution are important as it is used in determining risk and probabilities in many situations. It is frequently used in fields such as insurance, healthcare, and sales. More examples of applications are calculating the risk of an individual being in a car accident based on their age and number of driving citations received, determining the risk that someone will need major surgery based on BMI and cholesterol levels, and estimating how long a patient has had diabetes based on serum creatinine and fasting blood glucose level.
So that's all from us. Thank you.